Hi, today we're going to learn about the amines. If you look at the amines nomenclature, there are 4 examples I have given. If you look at the longest carbon chain with an amine group, which is NH2 group, you will write down the name of the longest carbon chain, propane 1-amine. The position of the amine will be written after writing the carbon chain. The second example I'm doing actually is when the nitrogen is attached with the 2 alkyl groups on each side. The first example is actually a primary amine where an NH group is actually attached with the 1 alkyl group. In this example, you have 2 alkyl groups attached with the nitrogen of the NH2 NH group, and that will be written as N-methyl propane 1-amine. Third example I have done when you have 3 different alkyl groups attached with the nitrogen. So that is an example of the tertiary amine. Amines actually are known in a different way in terms of primary, secondary and tertiary. When you talk about the alcohols and haloalkanes, is when the carbon attached to the OH group or chlorine is attached with 1, 2 or 3 carbon atom. It is then they are known as the primary, secondary and tertiary alcohol or haloalkane. In terms of amines, it is when nitrogen is actually attached with the 3 different alkyl groups. It is then they are known as the tertiary amine. So in this one, you can see the nitrogen is actually attached with the 3 alkyl groups. That's why it is known as a tertiary amine. When we actually do that, we will actually consider these 2 as a side chain. So you will write down NN. N is for the nitrogen. Both methyl groups are attached with the nitrogen, so it will be NN. Because there are 2, so NN dimethyl. And then the longest carbon chain is propane, so propane amine. That will be the name according to IUPAC system. The fourth example is when you have a longest carbon chain and you have an amine on the sides. Where you can look at the hexane 1,6-diamine. So you will actually write in the position of the amine group. Whenever you have the amine group in the longest carbon chain, you will name them after writing down the hydrocarbon, just like that. But it's just because there are 2 of them, so 1,6 are the position of the amino group on the longest carbon chain and di for 2 amino group. Now we're going to look at the amines basicity. Amines are actually basic in nature because they're lowly Bronsted base, where they actually donate a proton, donate a lone pair of electron to a hydrogen positive ion and make a bond, a dative covalent bond. Now when you look at it, there are 2 types of them. One is aliphatic amines and the other is actually aromatic amines. Aliphatic amines, in terms of primary, secondary and tertiary, the basicity is actually higher if you look at the tertiary amine, because there are 3 alkyl groups and alkyl groups are actually electron donating in nature, whereas the aromatic amines, they will not allow nitrogen to donate that electron pair easily to the proton. So in that case, the electron pair from the aromatic amines will be delocalized inside the benzene ring, and therefore it is not going to make a basic solution. Coming back to the reaction of the acid with the amine, for example, if I take an example of an amine, which is a methyl amine, I'm going to react with an acid which is HCl, and it will make CH3, NH3 and ammonium salt. So that is how it's gonna make. But if I treat this product with NaOH, sodium hydroxide, it will convert back into the amine itself. So this, and obviously it will actually make a water, and that's an extra product. So what we're going to do is we're going to look at the preparation of amines, and I'm going to quickly remove all of this where I can actually draw some mechanisms for preparing the amine. Now we're going to look at the preparation of amines. Now you will have an haloalkane like ethyl chloride, and you're going to react with ammonia in the ethanolic condition. Now ammonia will be an electron donating species, which will donate the electron pair to the carbon, because carbon is actually feeling a little bit down because of the difference of electronegativity between carbon and chlorine. Nitrogen will attack on the carbon, and that will make an intermediate which is CH3, CH2, NH3, and you will also get a chloride ion in the solution. That intermediate will carry positive charge because nitrogen has made 4 bonds. This will actually re-attack by ammonia. If I actually write it down, NH3 as like this, still acceptable, isn't it? Now this NH3 again will attack onto this hydrogen. Based on this, if I put the arrow towards the chlorine, this one remove the protons. The first step is the nucleophilic substitution. In the second step, ammonia will actually replace the proton, and that will make CH3, CH2, NH2 amine, and that NH4 positive ion, which will appear from there, will make a salt with the chlorine there. Now, if you want your desired product is actually the primary amine, you have to stop the reaction, but you cannot do further stop the further substitution. All you have to do is you have to use excess of ammonia. If you use excess of ammonia, that will actually stop the further substitution, and you will get the primary amine as your desired product. But if you wanted to make the secondary product, which is like a secondary amine, for example, if you have actually made a primary amine, and then you want to carry on forward to make the secondary amine, you will use the same thing, which is actually your starting material, haloalkane. The haloalkane will be attacked by the nitrogen from the primary amine, and that will make so this part will actually release the chlorine. So you will have chloride ion in the solution. Now, based on this, obviously, that again you can write this one down as hydrogen, and that will be attacked by your reactant, not by ammonia. So you will have your reactant there, which is obviously one of these primary amines. So primary amine will attack. So I'm going to write it down like that: CH3, CH2, NH2. Because you do not have an ammonia in the solution, that primary amine will re-attack on the extra proton you have there, which will carry positive charge there, because this is an intermediate and nitrogen has got 4 bonds. Once you've done that, it will straight away occupy that, and it will remove the proton from the nitrogen and will make a secondary amine, because nitrogen is connected with the 2 carbon atoms. And then after that, this one will be converted as a product as CH3, CH2, NH3 positive ion, and then Cl negative ion, and ammonium salt will be produced as well. Now, if I do not stop the reaction, it will carry on, and it will actually do the further substitution, and it will be converted into the tertiary amine. Now, aliphatic amines are pretty straightforward, where you actually carry on a re-attack by the primary haloalkanes, and you make first step is to make the primary amine, the second step is to make the secondary amine, and then after that you can make the third tertiary amine. I can actually do that for you straight away. If you have this haloalkane and you have made the secondary amine, you can go back and you will have a product which is made during the chemical reaction. So this is your secondary amine. You are going to react it with a primary amine, and that will actually allow this nitrogen, the haloalkane, and that nitrogen will attack on this carbon atom, which has carried a partial positive charge and chlorine partial negative charge. Now, you know that the intermediate will be formed first, which will be the CH3, CH2, NH, CH2, just like that, and that carbon will be attached itself to the nitrogen, and that will be CH2, CH3. And you will have an extra part of chlorine. Now, your starting material, obviously, this one is secondary amine. That will re-attack CH3, CH2, NH, CH2, CH3. That will attack back onto this nitrogen to remove this proton. So this nitrogen will attack onto this hydrogen and make a dative covalent bond, and hence you will actually make CH3, CH2, CH3 over there, CH2, CH3, and then you will make CH2, CH3. Nitrogen will not carry positive charge now because it is actually been removed. One of the protons is removed, the next extra product which you're gonna have after attacking the secondary amine onto the intermediate will be NH2 positive ion, and you will have a Cl negative ion, and ionic salt will be produced. So this is how you're gonna make the primary, secondary, and tertiary amine. Thank you very much.